And this is 2, 3 again. Multi-step equations. Say that again? Yeah, this is the basis of algebra. Solving for a variable. And you got to get good at it. If you don't get good at this now, it makes geometry hard, and it makes algebra 2 real hard, and it makes math for college readiness hard. Okay, you got some different values in the denominator. Okay, when you're dealing with these type of problems, the other day we had stuff like x minus 4 over 3 equaled 10. And what was the first step to solve this equation, Brandon? Yeah, you multiplied each side by 3, and you had x minus 4 equaled 30, and then you added 4, and x equaled 34. So we basically multiplied by the denominator to get rid of the denominator, right? The same type of technique works here, but you got to get a little more creative in your thinking, because the denominators aren't the same, are they? Okay? So you've got to pick a number to multiply both sides by. Stay focused. You got to pick a number to multiply both sides by, so that when you do that, you get rid of both denominators. Okay? And right now, since these values are pretty small, what do you think you could multiply both sides of the equation by to get rid of a 4 and a 3? 12. Why? Because they both go into 12 evenly, and they'll cancel out, won't they? Alright? So now, really pay attention here. If you multiply the left side by 12, you got to multiply the right side by 12. Alright? But look, this 12 gets multiplied by this and this. You have to distribute it. Okay? So what I like to do is, instead of doing these arrows, I'm going to do 12. I'm going to do it like that. Okay? Going to multiply everything in the equation by 12. So watch what happens. The 4 and the 12, they cross cancel, don't they? 4 goes into itself once, and it goes into 12 3 times. And what's 3 times 3x? 9x. Okay? Minus 3 goes into itself once, and it goes into 12 4 times. And 4 times x is 4x. 10 times 12 is 120. Now what? Sarah? Combine like terms. Good. 9x minus 4x is 5x equals 120. So if 5x is equal to 120, your next step would be to divide by 5, and x is going to equal 24. Okay? So try this. 2b over 5 plus 2 over 4 equals 5 over 2. What can you multiply through by to clean this up? 20. Why'd you pick 20? Because 2, 4, and 5 all go into 20 evenly, don't they? Yes? All the denominators. Because you want to get rid of those.
So, like, in the other one, when it's equal to 10, you just have to find it for 4 and 3.
Yeah, because 10 was over 1. And then, yeah, it's a whole number. We don't have to mess with it. You guys don't like the way you guys don't like fractions, do you?
No.
So what do you do with something you don't like? You get rid of it. Okay? You got a friend at your party, you got someone at your party you don't like, you get rid of them. You got someone in your group you don't like, you get rid of them. You got food on your plate you don't like, you get rid of it. Feed it to the dog. You got fractions in your problem you don't like, get rid of them. And this is the technique to get rid of them. So if you multiply everything in this problem by, what did we say, 20? So we're going to go times 20. This gets tight, so it's times 20 and it's times 20. Five goes into itself once and it goes into 20 4 times. And 4 times 2b is 8b. Plus 4 goes into itself once, it goes into 20 5 times, and 5 times 2 is 2 goes into itself once and it goes into 20, and 5 times 10 is subtract 10 from each side. 8b is equal to 40, divide by 8, and b equals 5. Let's try another one. 1/9 equals. And when you're doing these type of problems, if you leave a little more space in between everything, it makes it easier when you start to multiply. 5, 6 minus m over 3. Multiply through by y. 18 y. 9, 6, and 3 all go into 18. If you did 6, 9 doesn't go into 6 evenly. So you wouldn't get 9 out of the denominator. You're looking for a number that all of these denominators go into evenly. 9 goes into 18, right? So we're going to times 18 and we're going to times 18. So 9 into itself goes once and it goes into 18 twice. 2 times 1 is 2. 6 into itself 1 and into 18. 3 times 5 is 15. 6 times m is, now that's minus 6m. So subtract 15. 2 minus 15 is 2 minus 15, negative 13 equals negative 6m. That doesn't look real clean, does it? It's alright. Divide by negative 6, good. Now over here on the left side, a negative divided by a negative equals a. Good, so this becomes 13 over 6. This is 15 minus 6m. This is a positive 15 right here. Since that's a positive 15, you're going to subtract 15 from each side. I don't have any. Somebody probably should, yeah.
There is no office. Why are you there?
Go to the custodian's office across from the clinic. Go
Custodian?
across from the clinic. Yep. Just leave that 13.6 the way it is. Yeah.
Because basic 18 could use these 3.
Say that again.
Basic 18 could use these 3.
Instead of 18?
Yeah.
No, because we want something that 9, 6, and 3 go into.
Okay.
Alright? 3 goes into 3, 6, and 9. But that wouldn't help us get rid of the denominator. Alright, the next example they cover here in the book is just on page 106, solving an equation that contains decimals. .5 minus 0.02x equals 1.24. There's nothing different about this problem than There's nothing different about this problem than any of the other whole number problems we did, is there? You're going to subtract 3.5, right? And subtract 3.5. So you get a negative 0.02x equals... You're allowed to use calculators, so just do it right now. 1.24 minus 3.5. No. 2.26? Okay. And what are you going to divide by? Negative 0.02. So x is going to equal 1.13. 2.26 divided by 0.02. You got what? 2.28. No. 113? That sounds better. 113. Thank you. Now, is this answer going to be positive or negative? Positive, because look, you had a negative divided by a negative. Okay? So when you're dealing with the decimals, that's just like what we did yesterday. But you just got to be careful with your decimal places when you're typing it in the calculator. Question? Dan? I can't hear you, buddy. Yeah, I know there's not supposed to be one there either. It's just... Questions? Alright, today you're going to do page 106. Page 106, 1 through 3, and then 8 through 18.